Hello students, in this session we will discuss about the number system. Okay, so you heard about different type of number system which are used in the computer. So uh, there are different the number in a computer system are represented using the two different categories or groups. One is the positional and next one is the non-positional. Okay, so you can see in a computer number system that the number is represented using the 2a. So is that a is possible in a number system? Uh, Maybe because A is an alphabet, so how we can reuse it in a number system? Yes, we use it in a hexadecimal number system. Don't worry. Like 52. Okay, 52 is fine because both are the integer values. 42, it's okay. Now there is something 62, 8, and 10. So can you suggest me what is this? Okay, these are the bases. So here we show that this number 2a is represented into the using the base 16, or we can say using the hexadecimal number system. Next, here is the 8. That means the range of the number is from 0 to 7, and it is using represented using the octal number system. Okay. So next is the 42 and the base is 10. Okay, this is the normal number system. Okay, decimal number system. So we see here the number can be represented using the hexadecimal number system, octal number system, and the decimal number system. And the numbers are represented in a two different category. One is the positional and next one is the non-positional. Okay, as the name suggests, the position, that means the weightage is added to their position. Now we can see 1, 3, 5, 8. Now 8 is on the least significant position, and 1 is on the most significant position. So the 8 is multi and the number is in what format? Base 10. Now, what we have to do and how we got the number? The every bit is having the weightage. The least significant bit having the weightage 0, this one is 1, this one is 2, and this one is 3. Now, if we want to convert the same number into the decimal number system and itself base is 10, now what we have to do, we have to just mention 10 and the power is 0. Okay, and we multiply it by using the value itself. Now 8 is multiplied by what? 10, because the weightage is 0, the power will be 0. Now 5 is multiplied with 10, 10 to the power 1. The 3 is represented using 3 and the multiplied with power 10 to the power 2, and 1 is multiplied with 10 to the power 3. So these are represents the power, and the base is 10. Okay, this one base is what? 10, and we got the number. Now if there is an decimal, okay, point, then the powers will be converted into the -1 and -2, -3. So the power is increased in this direction, whereas from the point in a integer value, the powers are from 0 to 1, 2, 3 increment level, whereas after the point the powers is start from -1, -2, -3, and so on. Okay, now in a non-positional, or non-positional means non-weightage number system. Now in a non weighted number system, the digit the value is independent from its position, and the example of this number system is gray code system, Roman code system, Axis 3 code, etc. These are the non-positional or non-weighted number systems. Now the different type of number system. The numbers, the weightage number systems are represented using the four different number system. One is the decimal, next binary, octal, and hexadecimal. So how they are different from each other? Now, as the name suggests, decimal. So the base of the decimal number system is 10, which is also called radix. Okay, this one radix. Sometimes the examiner asks what is radix. So radix is the base of the number. Like here is the number 1, 2, and if we mention the base is 10, then the radix is 10. If we represent the base is 8, then it is the what? Octal number system. If we represent a number using the 1, 0, and we mention over here 2, then the number system is what? Binary number system. And in a hexadecimal number, the base is 16. So can you remember decimal means 10, so the base is 10. Binary, by means 0 or 1, that means 2, so the base is 2. Octal means oct means 10, 8, so the base is 8. Hexa means 16, so the base is 16. Okay. Now here you can see the base of decimal 10, binary 2, octal 8, hexadecimal 16. Now the range is reflected using this base. Okay, if the base is 10, then the range is start from 0 to 9. So range is always start from 0 up to what? Base minus 1. Okay. Now in a binary, the base is 2, so the range is 0 to 1. In octal, the base is 8, so the range is 0 to 7. In a hexadecimal, the base is 16. Now, what we have to do? After 9, the 10 is represented using what? A. 11 is represented using what? B. Okay, so don't got confused here. A, B, C, D is nothing but 10, 11, 12, 13, 14, 15. Okay, this one is the 15 and this one is the 11, 10, sorry. Okay, okay. So A is represented what? A and F is represented using the 15. Like the same numbers you can see them in a paint. Okay, where F, 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 that means 15. Okay, F. So whether are used by humans? Yes, the number system of decimal is used by humans, whereas these number systems are represented only in a computer. Okay, so the computer is used only binary number system, but developers can understand the binary octal and hexadecimal. Okay. Now the quantities and countings. So in a binary number system, the 0 is represented using what? 0, 1 is representing what? 1, now 2. Now you can see in a binary there is a no concept of 2 because the range of binary number system is start from 0 to 1. So there are only two number which can be 0 or 1. So how we represent 2? So we extend one more position and then the next after 1, what is the 0 1 combination? So 1 and 0. After 1 and 0, what is the next 0 1 combination? 1 1. After 1 1, okay, 1 0 0. What we do? We just add 1 1 digit in in this number. Okay, so when 1 0 is added with what? 1, then we got 3, which is 1 plus 0 1 1 plus 0 1. Now after adding 1 in this number, what we got? 1 plus 1 0 1. So carry here is 1. Now 1 plus 1 0 and there is an carry again. So this one. Again what we have to do? We have to add 1. So 1 plus 0 1 0 and 1. Okay. So that's how we got the next number. In octal number system, the range is number is start from 0 to 7 because the base is what? 8 and the range is 0 to 7. Here the base is 2, here the base is 16. Okay, so the values are start from 0 to 7. So that's fine. The decimal from 0 to 7 is directly converted into the octal and the same hexadecimal, because the hexadecimal is range from 0 to 15, which is F. Okay, so 0 to F, don't got confused. So 0 to 7 of the decimal is directly represented using the hexadecimal. Now come to the 8. Okay, now in octal number system 7 was there. Now in adding the 7 1, what we got? 7 uh, plus 1, what we got, because there is a saturation on 8, so 0 and 1 is there, so 1 0 1 0. After adding 1 in this number, what we got? 11, 11 plus 1 and so on. In a hexadecimal number system 8 9, we directly convert 8 into 8, 9 into 9. What about 10? Now there is no concept of 1 0 in a hexadecimal, and 1 0 is 10 is represented using the A. So here 10 is represented using what? A. So instead of 10, we write it here A, B, C, D, E, F. Okay. The octal number, the decimal number of 15 is represented using the 17 in a octal number system. Okay. Now again the 16 is represented using 1 0 0 0 0 and 20 in a octal number system, and in a hexadecimal number it is 1 0. Okay. So after this F, because in a 15, decimal value of 15 is representing what? F. When we add 1 in a F, what we got? 0 and the carry 1, so carry here. Okay, so that's how we got the numbers. Now the conversion among the bases, how we convert one number system and into the another number system, and that is the most important part in the number system, which is called the type conversion, where what we have to do, we have to change the bases. Like if we want to get the decimal value into the octal value, decimal to the binary, base to binary to the hexadecimal, which is having the base 16. So how we convert them? So that this will so this is some one of the example how we represent 25 into the base 10, and how we convert it into the binary, and how the binary is converted into the octal, and how the octal is converted into the hexadecimal, or how the decimal is converted into the octal, how the octal is converted into this one, and how this one is represented and the its reverse. So these things we will discuss into the next session. If there is an query, you can comment in a comment section. Thank you.